Hi everyone, so this is an overview of Pre-Calculus Lesson 7-2. We're talking about the addition and subtraction formulas for our trig functions. So you'll notice that I have the 6 formulas written out on my board. And essentially what we're going to do is we're going to start off with some questions where we have a value here that would be the addition of some of these angles that we see on our unit circle. And we're going to take those and actually put them into this formula over here and figure out some values. And then we're going to go the opposite direction. So I'm going to give you something that looks like this, and we're going to go in the opposite direction to get something that's on our unit circle. And the goal of this is to actually find exact values for things that are not actually on our unit circle. So our first question is the cosine of 75 degrees. So I'm going to come down here and find my degrees, and I'm going to say which two of these would add or subtract to get you 75. And I notice that 30 plus 45 is 75, so that's what I'm going to use. So instead of doing the cosine of 75, I'm going to change this into the cosine of 30 plus 45. And then I'm going to go and use the cosine addition formula to find out what this is actually equal to. So S is going to be 30 and T is going to be 45. So this is cosine 30, cosine 45. And in this formula, notice it's adding, but they switch the sign right there. So just be careful when you're copying it. So minus the sine of 30, sine of 45. Now I'm going to use my unit circle to plug in values for these. On the unit circle, I find out that the cosine of 45 is square root 2 over 2, and the sine of 45 is square root 2 over 2. I'm also going to find that cosine at 30 degrees is square root 3 over 2, and sine at 30 degrees is 1/2. Now I'm just going to multiply these out and simplify my fractions. When I multiply this, square root 3 times square root 2, I get square root of 6, and 2 times 2 is 4. And it's minus 1 times square root 2 over 2 times 2, which is 4. Now, simplifying this, I can just combine this into one big fraction to get the square root of 6 minus the square root of 2 all over 4. And that's my answer for that first question. The cosine of 75 degrees is actually this. So we're going to do it again, but this time with radians. Pi over 12. Now notice all of these values from our unit circle, and I haven't copied all of them, I've only copied some. They don't have common denominators. So in order to tell what they would be if I added or subtracted them, I'm going to need to change them into common denominators. And that's why I have all these equal signs. So the common denominator for 6, 4, and 3 is 12. So this is going to be 2 pi over 12. This will be 3 pi over 12. 4 pi over 12. These are all my common denominators. 6 pi over 12. This will be 8 pi over 12. And of course you could keep going. I'm just doing these few. This is going to be 9 pi over 12. Okay, and that's plenty for what I need because I just need 2 that can add or subtract to get pi over 12. And I notice that these first 2, if I subtract them, if I do 3 pi over 12 minus 2 pi over 12, I will get 1 pi over 12. So if I subtract these two, it will work. So what I'm really doing, and I'm going to erase my previous answer because I need the room, is I'm doing cosine of this one minus this one, or pi over 4 minus pi over 6. And I always go back to the notation that was on the unit circle, so I don't accidentally get confused and do the wrong one. So I always keep this on the side of my page, and I always go back to what's in the unit circle. Now we're going to apply the cosine subtraction formula, and that is cosine of the first times cosine of the second plus sine of the first, sine of the second, meaning the first angle and the second angle, first and second. Now I'm just going to plug in values from my unit circle. Cosine at pi over 4 is square root 2 over 2, and sine at pi over 4 is square root 2 over 2. Cosine at pi over 6 is square root 3 over 2, and sine at pi over 6 is 1/2. So I'll multiply these and combine my like terms. This becomes square root 6 over 4. This becomes square root 2 over 4. And if I add them, I get square root 6 plus square root 2 over 4. And that's my final answer here. It is exact because I didn't round those square roots. And if you type that into your calculator and hit enter, you're going to get the same answer as if you're in radian mode and you type this in. But that's not an exact answer. This is exact. No decimals when they say exact. So those are our first two examples where you just have to figure out values that add or subtract to get the angle that they gave. Now what we're going to do is we're going to work backwards with this. And we're going to say this was what was given to us, and we're going to figure out from this side of the equation what we would have over here. So notice they've mixed sines and cosines, and there's addition happening. And that's up here. Sine addition is sine cosine plus cosine sine. That's exactly what I have. So I'm using the sine addition formula. So sine of S was 20 and T was 40. 20 plus 40 is 60. So now all I need to do is go to my unit circle to find the sine of 60 degrees. At 60 degrees, sine is the square root of 3 over 2. And that's my answer for that one. And I'm done. That is my exact value for that. So if they give you something complicated like this, look at your formulas and see if there is one that will work. Okay? So those are the most basic questions where you're just plugging in things to the formulas. Now we're going to move on to a question where we have to prove an identity. So we need to prove the identity cosine pi over 2 minus u equals sine u. Now, please notice this is a subtraction formula, cosine subtraction. So we're going to start by simplifying this. And I'm just going to put it into the formula. This is cosine of pi over 2, cosine u, minus sine of pi over 2, sine of u. So this side, I used the cosine subtraction formula. And I just put in what I was given. Now I'm going to get values from the circle, from the unit circle specifically. Cosine at pi over 2, I can do that. That's 0. And it's times cosine u. Sine of pi over 2 I can do as well. That's on my unit circle. That's 1 times sine of u. Now I'll just do my multiplication. 0 times this is 0, so this just cancels out. Negative 1 times this is, oops, this should be plus. Sorry, I copied my formula wrong. 1 times sine u is sine u. And this is what I needed to show it equaled. So I am done. I changed this side so that it looks like this side. And that's what we do in identities. You pick a side, usually the more complicated one, simplify it out to see if you can get the other side. Okay, so these few questions are the easiest type of questions you'll see. I'm going to make another video with some of the harder types of questions.